So welcome back everyone. Example number 2 from chapter 7. Jumping right in. We've got a problem here that looks at this scenario dealing with executive training. There was a survey conducted with the Association of Executive Search Consultants, and the survey showed that 75% of 300 CEOs polled believe that companies should have fast-track training programs. Now, suppose we wish to use these results to justify the claim that more than 70% of CEOs believe that companies should have a fast track training program. Now, this justification of the claim task that we're doing here will be looked at much more in detail in chapter 9 when we look at hypothesis testing. But this is a good way to start. We can do some of that even with the bare minimums here in chapter 7. And assuming that 300 surveyed CEOs were randomly selected, meaning the sample was properly taken, and assuming for the sake of argument that 70% of CEOs do believe that companies should have a fast-track training program, calculate the probability of observing a sample proportion of 75% or more, meaning what is the chance of taking a random sample and actually finding out that more than 75% of the respondents agree with a certain statement. So step one, essentially it is only one step, is to recognize we have to calculate the Z value for this problem. So let's jump right into that. We're looking for the probability that P bar is greater than or equal to 0.75, and that will be equal to the probability of Z greater than or equal to some number. And so that some number, we're going to do that right now. So Z is going to be equal to P bar minus U over P. Okay, so we recognize that this is the standard error, and the standard error is essentially nothing more than P times 1 minus P divided by N, and take the square root of that. Okay, so 0.75 minus 0.70 divided by 0.70 times 0.3. Our sample size is 300, and that should get us a value for Z. So here I have 1.89. Always check my math just in case. We're going to put that right there. So what is the probability that Z is greater than or equal to 1.89? Now notice that if you'd like to check, you can double check and see that the sample is large. N times P is indeed greater than or equal to 5. N times 1 minus P is also greater than or equal to 5. They both check out, so the sample size is large. Therefore, we can use the standard normal distribution table. So I'm just going to clean this up here. And I'm going to write 1.89 here. I go to my standard normal table. 1.8 is right there. Need to go all the way to the end just to verify that this is indeed 1.89. So the probability of being between 0 and 1.89 is right there. That's 47%, 47.06. And so because we were looking for greater than, so what we're going to do is 50% minus 0.4706 for a grand total of 0.0294, which is equal to 2.94%. Okay, so a pretty small chance of actually finding a sample with a proportion that big or bigger, which leads us to the next point, which says, based on the probability you computed, which is 2.94, would you conclude that more than 70% of CEOs believe that companies should have fast-track training program or not? Well, the answer to this is obviously that yes, the probability of observing a sample proportion of 75 or more is small, and therefore the true P is probably greater than 70%. So the fact that you actually observed a sample, which is stated here, you actually took a sample and found that 75% of that sample responded in a certain way, it's an indicator that the real average is essentially way too low. So just as an extra explanation, here is where the theory says you should be. You should be around here. We know from the empirical rule that 68% of things should be around the average. But here you are, on your first sample, you took a sample and you found that the sample average was 75%. And this area here is 2.94%. So the fact that you observed something that is technically rare indicates that maybe you miscalculated this value. In fact, it should be maybe, I don't know, maybe it's 74%, and therefore makes this guy not seem so strange. So the fact that you observed something that you shouldn't be observing gives you an indicator that maybe you're measuring your starting point incorrectly. Your starting point is a lot closer than what you previously assumed.